we're told that we have an arithmetic sequence. Here's our fifth term and our ninth term. Find the first term. So 1, 2, 3, 4. Fifth term, 32. That's our a sub 5. Here's our a sub 1 back here. Sixth, seventh, eighth, and the ninth term will be 70, a sub 9. Now again, if you want to go guessing, you can play around with what value we might be adding to go from term to term to term. But what if it's a fraction? I'm going to rip off the first four terms, relabel the fifth term to be the first term. I'm subtracting 4 from the subscripts, and so the ninth term is going to turn into now the fifth term when I subtract 4. I don't have any sums involved, so I will be using the a sub n formula for arithmetic sequences. And here we go. A sub n becomes 70. The first term is 32. 70 was our fifth term, so n is 5, and we will have 5 minus 1 times d. When we subtract 32 on both sides, we're going to get 38 on the left equals 4d, and this is not a nice clean value of d. It turns out that d after reducing is 19 halves. Okay, now it's time to go back to our original subscripts because we need the real a1 to show up here. So I'm going to go back and rewrite our nth term formula. A sub n equals a1 plus n minus 1t. Now, what will be our a sub n? Rather than using 70, let's use 32 because the numbers are smaller, and that is our fifth term as it was originally presented. So 32 is equal to a1 plus 5, because 32 was the fifth term, minus 1, times 19 over 2. Notice this becomes a 4 inside the parentheses, which cancels with the 2. So we get 2 times 19, which is 38. 32 equals a1 plus 38. And a1, after subtracting 38 on each side, is equal to negative 6. And that's what we're looking for. Determine whether each is arithmetic or geometric, and then find a formula for the general term an. Okay, I'm looking at this, add 6, add 6, add 6. Okay, add 6 is what we notice first off the bat, and that will mean we have an arithmetic sequence. Our nth term formula here is a1 plus n minus 1d. So let's see what we have. a1 is 5 plus n minus 1 times 6. We have 5 plus 6n minus 6, and we can write that the nth term can be represented by 6n minus 1. That went pretty easily. Let's try the next one. 4, 12, 36. We can see here that we are multiplying by 3, and that tells us we're dealing with a geometric sequence. And the formula for the nth term of a geometric sequence is a1 times r n minus 1 times. So we can write that a sub n is equal to 4, our first term, multiplied by the ratio 3 to the n minus first power.